Hello, AP Pre-Cal kids. This is me trying to do a video tutorial about this project. And I'm making this because maybe my directions aren't the most clear. So here's me trying to kind of clarify stuff. But if you still have any questions, please ask me or Miss Kim, and we should definitely put you in the right path to do this successfully. Okay, so I'm going to read it. So in this creative math project, you will write your name using functions in Desmos and on paper. Your name will be created using restricted domains and ranges, meaning you will control the domain and range of each function to match the shape of your name's letters. So if your name is Bill Jewell, you are going to make a capital B, lowercase I, lowercase l with a space and a capital J, EWELL, all using the types of functions you've been taught in pre-calculus, and you're going to restrict the domains to make the lines look like how they should look in letters. And you're going to do that on Desmos and paper. And as I'm going to say this repeatedly, test this out on Desmos first, make sure it looks good on Desmos first, and then you can more or less just copy what you made on Desmos on paper. So what you're going to do is you're going to do this, write your full name, and your full name has to be at least 10 letters total. If your first and last name don't add up to 10 letters, then put in a middle name, put in something else, mother's maiden name, I don't know, but it needs to be at least 10 letters. So since it's a 10-letter minimum, you can use, like if you can use a shortened name, like I'm using the late name Bill, which I could be using the name William instead. But since I'm trying to fulfill my requirements, I would use Bill instead. And you're going to do this in print, and you're going to do this cursive. So print means print letters, basic, print letters, which we should all know what I mean by print. Print letters, like basic A, B, C, like just that. Okay, so as you look at print letters, it's mostly like diagonal linear lines, horizontal linear lines, vertical lines. That's just what it is. But you do have cursive involved also. I mean, you have curving lines too, like C and G and Q and P. There's actual curves you have to do in print, and then cursive. All right, cursive is basically everything's a curve, and when you accurately, appropriately write in cursive, the letters of the same word connect. Like that's actually part of writing cursive. So the letters of the last name must connect in cursive, and the first name too. If you're not used to using cursive, which you should, at least for like having a signature. I mean, everybody in America should have a signature. You have to sign things like checks and contracts and stuff. So you should have a some form of cursive. I do not. I mean, in my own personal opinion, do not have a signature that's just block print letters. It'll make it easier to forge your signature, and also it doesn't look good. So when I say cursive, I'm talking about like these. These are lowercase cursive, and they would connect to each other. This is one way to do capital. Let's see. Yeah, I agree with these. These are capital letters. So this is a link that I put here if you don't know what cursive looks like. And you're going to recreate your printed in cursive name Desmos and on grid paper using mathematical functions. Use functions to draw each segment of your letters. I'll demonstrate how to do that in a minute. Each part of your letter must be created with at least one equation, and that is absolutely true for really even the most simplest letters, like lowercase I involves two things, because you got the vertical line and you got the dot. Those are separate things. And you do that via restricting domain or range, which I'll show how to do on Desmos. And your name must at least include 8 visible curves, which will definitely happen. Like, I know 8 sounds like a lot, but when you do this project, you'll probably go through 8 curves within not very long, especially the cursive part of this. And you have to use at least 2 of each of these types of functions. These are the main types of functions that we taught you in AP Calculus. quadratic, polynomial, rational, exponential, logarithmic, and trigonomic. So I'm going to print out this, but more helpful is the digital version of this document, because you can click on these links if you don't even know what those look like or what they should be. Like, here's me trying to give you links of explanations of how to do this or what they should look like. All right, so what do you turn into me? You turn in a screenshot or a shared link of your Desmos graph and the equations, the domains range used. If you screenshot all this, which I'll be honest with you, you're gonna have to do more than one screenshot. Like, it's probably multiple, because you have to screenshot possibly for each letter you do. That's probably the maximum amount of screenshots, or maybe for each name, like you do a first name screenshot, a last name screenshot, and you'd have to do that for both print and cursive, probably. And you would either Google Share or email it to me. And the paper copy of it. So the paper copy of it is, now I'll print out some grid line paper for you, but I highly recommend you do that yourself. You're probably one 8x11 piece of paper is not enough to do this. So I'd almost like use many of them, maybe on like paste them on a piece of poster paper, or just kind of, you can probably just hand them all in to me. That'd be fine. So what I have here is, okay, let's say if you want to like make your own coordinate plane, I would use probably multiple versions of, like, I would print out, maybe a few of these. I mean, it's okay if you have these axes, you can probably take that off. Here's a variety of different ones you can take via that website. Or what I did here is, I just kind of made a document of just, here's a bunch of grids, and I would print out multiple copies of this and kind of paste them all together. And that would be the graphing part of the paper section. So like this is digitally here, but you're gonna have to print this out and actually try drawing it accurately. And then on this graphic organizer here, you this is where you'd put your equations and domain range. Okay, so you're going to edit the size and columns of this document. Okay, don't just print it out. You need to change how big the rows and columns are in order to fit what you made. Okay, so you're going to make this on Desmos first, and then you're going to do paper. I do not do paper first. That would be an insane waste of time. Do it on Desmos first. So, so this document, which you make a copy of yourself, is okay. So here I have all these rows, but like, so each row, like you put, I'm doing capital B. And then here you'd have to write really all the functions you use to make the capital B. And that's why I'm saying you might have to, like, this is going to get bigger. Like if you write a whole bunch of y equals, f of x equals, all this stuff is going to get bigger, bigger, bigger. So prior to printing, this out, you need to like make it bigger, make it smaller, maybe change, since it's just writing a capital B, make this, so go over here or whatever. But you make your own copy first and you change it. And then here you write the restricted domains and ranges using interval notation. Meaning you go like D, this, and then bracket, 3 to 5, bracket, that's domain, and then range is, but you'd have to do that for every equation you use. And also, like, sometimes you restrict domain, sometimes you restrict range. You don't have to do both. Frankly, you don't have to do both. I'll show you why in a minute. And yeah, so the way that you connect the printed graph to the printed equations is that you would write the equations in function notation, like F, G, H and A, and so on. If you actually like run out of letters of the alphabet, you'd go double, basically. Yeah, like if you run out of letters, you use combos of letters, like instead of it being like A of X, you'd be like AB is for AB power X, or like FG You know, like you would actually could use combos of letters. Um, and that actually like exponentially gives you more combinations to do. And you print it out, handwrite your data, and turn it when you're done. So if you just try to type this, I will not count this. Like I typed the letter B, but you're not going to type. You're going to write B. Okay. Don't do that. All right. And then on the bottom of this graphic organizer, you're going to write reflection answers to this. These are these questions. And here is the rubric of how I'm going to grade this. This is an exam grade. Please give me a good exam grade. And here I have examples of how I would do this on Desmos. So like if you do this, like if like this is all the information I made to make capital B, printed and cursive. If you notice, they're almost exactly the same, but the differences are like if you look at the top one where it says x equals 2, that makes the vertical line here. Okay, that makes a straight vertical line. But when it comes to like the cursive one, I can't really use straight lines. So this one down here, it says y equals -3 log negative x plus 2 minus 3 with this range, that is actually that curve. And so you see the braces are what create the domains and ranges. And notice that you don't have to do domain and range for either of them. For example, like x equals 2, you don't have to do domain. The domain is 2. Okay, what you do is you have to restrict the range to make it stop going up and stop going down. Same with the blue, that does that. So that this purple one here is this kind of upper part here where it says y equals cosine x plus 1 plus 3. That I have to restrict the domain to make it only go so far left and make it go so far right. So depending on what you want to make, it's like you either restrict how far left and right it goes or you restrict how far up and down it goes. You don't have to do both. And notice I never use both. I just kind of figured out based on what I want the line to look like. Am I going to restrict how far left and right it goes or how far up and down it goes? And so this is really about kind of playing around with it. You just kind of got to kind of play around with it. What I mean by playing around with it is if I were to go to Desmos and I were to like try making what this is going to look like, you know, if I want to make, let's say, I don't know, like a capital A. So I go like f of x is, all right, capital A is going to be like some sort of linear function, say plus 2, like this, plus 1. And then I do a brace to change I want the domain to not be so big. X plus 3, so now I have that. And then I want to make the other side of that. So g of x is negative x because I want a negative slope, but I need to translate the heck out of that. So that needs to go up a little more. I don't know. Let's go 3. What are you doing? 3. Okay, that doesn't work. What about 9? What about 7? Okay. So you notice I kind of have to play around with it to really kind of figure out what I want to do. I then need to restrict the domain, or let's restrict the range. The range would be between 4 to 2. So now I'm going 4, 2. No. Why didn't that do that? Okay, let's restrict so sometimes it won't work, and so you gotta kind of fool around with it. So like this is, so sometimes like, you know, domain won't work or something, so you gotta kind of test it out. 5, so now I have that, so great. Did that, and then I need to make a horizontal line that kind of goes through the middle of it. Y equals, let's just call it h of x, whatever. H of x equals, you make it equal a number that creates a horizontal line. Like that, and then I restrict the domain between 2 and 4. And I just made a capital A. Okay. I know that I just use all linear stuff. You got to do curves. I don't really have enough time. This video can only be 15 minutes. So that was the end of this. I hope this is helpful. Ask me for any help if you need help. Okay. Bye-bye.